Suppose you have 2 points. For example, take this point and this point. How many circles can pass through these 2 points, such as this one? Or if you think about it, the center of the circle must lie on the perpendicular bisector of this segment, because every point on the perpendicular bisector is such that this length equals this length. And we need these two to be equal because this is a radius in the circle and this is a radius in the circle. This means that if we start moving the center along the perpendicular bisector, then we get more and more circles that all pass through these 2 points. Now suppose I draw a third point here. How many circles pass through this point, and the new third point? Well, only one, and you can see this by moving the center a little bit more, like this. So we can see that there's only one possible location of the center for which the 3 points lie on the circle. And as we've shown that the center lies on this perpendicular bisector, we can show that the center lies on this perpendicular bisector and this perpendicular bisector as well. And so the 3 perpendicular bisectors in a triangle intersect at the point that is the center of the circle that passes through these points. This is called the circumcenter of the triangle, and so we've shown that the 3 perpendicular bisectors in a triangle intersect at the circumcenter of this triangle. So here's how the full picture looks like. We have the 3 perpendicular bisectors in green, and in blue we see the 3 radii that are equal. And this circle we call the circumcircle of the triangle. So here's a triangle, its circumcircle and its circumcenter, and the 3 radii that are equal. Now suppose this angle here is x and this angle here is y. Then because of the isosceles triangle here and the isosceles triangle here, we have that this angle here is x and this angle here is y. And so the angle here is 180 degrees minus 2 times x, and this angle is 180 degrees minus 2 times y. But the whole angle here is 360 degrees around the center of the circle. And so the remaining angle here would complement these two to 360 degrees. So 180 minus 2y plus 180 minus 2x plus this angle is 360 degrees, with a 2y plus 2x here. So in conclusion, we found that if this angle here is y plus x, then this angle here with the center of the circle should be twice as much, 2y plus 2x. So we can write this as follows. If this angle, the whole angle, is gamma, then this angle here is 2 times gamma. And similarly, if we have alpha here, this is 2 times alpha, and if we have beta here, this is 2 times beta. Furthermore, this isosceles triangle here gives us that this angle equals this angle, but their sum equals 180 minus 2 gamma. So each of them must equal 90 minus gamma. Similarly, we can find the angles in the other 2 isosceles triangles. So this here is the full picture that we get with all the angles. You may have noticed that the circumcenter of the triangle lies inside of the triangle itself, but that could have not been the case. For example, if this point, if we moved it right here, then this would be the triangle, and the circumcenter would still be here. So let's see what happens if the circumcenter lies outside of the triangle. Here's an example of a triangle where the center lies outside of the triangle itself. Similarly to what we did before, we're going to denote this angle by x and this whole angle by y. Then this triangle is isosceles, and therefore this angle x comes here. This angle y comes here because this triangle is isosceles. The sum of the angles in this triangle is 180 degrees, so this angle here is 180 minus 2y. And same for this triangle, where this whole angle is 180 minus 2x. So the angle here would be the difference between these two. So the large one is 180 minus 2x, and the small one is 180 minus 2y. So the difference would be 2y minus 2x. But note that this is exactly 2 times this angle here, because it is y minus x is this angle, and this is twice that angle. And so again, as with the previous case, we got that this angle here is twice this angle here. So to summarize, if this angle in the triangle is gamma, you can see that it points towards this side. And then we take the third vertex to be the center of the circle instead of the third vertex of the triangle. And then the angle that points towards the same side, coming from the center of the circle, is twice as big. So this is 2 times gamma. Similarly, if this angle is beta, this angle here will be 2 times beta. The equivalent of alpha is a bit hidden, but it's still easy to see. So if this angle is alpha, now alpha is more than 90 degrees. And so 2 times alpha will be more than 180 degrees. So 2 times alpha will be this angle right here. For example, you can see this by calculating that 2 times alpha plus 2 times beta plus 2 times gamma gives 360 degrees, because after all, the sum of alpha, beta, and gamma is the sum of the angles in a triangle, which is 180. Now we can use the three isosceles triangles to find the rest of the angles in the picture. For example, in this triangle, it is isosceles, and this angle is 2 times gamma, so the sum of this one and this one is 180 minus 2 times gamma, but they're equal, so each of them should be 90 minus gamma. Same for this triangle, this is 90 minus beta, this is 90 minus beta, and this is 2 times beta. And for this triangle, we have that this angle here is 360 minus 2 times alpha, and so these two must equal alpha minus 90 degrees, because that's the only way in which when we take the sum of this, and 360 minus 2 alpha, we get 180 degrees. So the conclusion is, when we have a triangle and a circumcenter, we can derive all the angles in the picture, just by using isosceles triangles and their properties. The natural question to ask here is, when does the center of the triangle lie inside of it, and when does it lie outside? One property that is very useful here is that if we draw the diameter of the circle, and we take a random point on the circle, then the angle that we get is 90 degrees, because the median in the right triangle always equals half of the hypotenuse. Therefore, for a triangle that has a right angle, the center lies on its hypotenuse. Now let's see what happens if we decrease the right angle a little bit. So if we make it smaller, like this, then in our new triangle, this triangle, the center lies inside of the triangle. And now let's see what happens if we make the angle larger than 90 degrees. And then this is our triangle now. The center now lies outside of the triangle. And so the answer is, if all the three angles in a triangle are less than 90 degrees, then the center lies inside. If one of the angles is 90 degrees, then the center lies on the hypotenuse. It is the midpoint of the hypotenuse. And if one of the angles is larger than 90 degrees, then the center lies outside of the triangle. So let's recap. Suppose that I have 2 points on the circle. Then, for a fixed circle, this angle here is fixed, and I'm going to call it 2 times gamma. Then I'm going to choose a random point on the circle, and I'm going to connect this point to the 2 existing points, like this. Then I know for sure that this angle is twice as large as this angle, and so the angle here is gamma, and it's always gamma. It doesn't matter if I chose the point here, 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 or here. It's always gamma, because this angle is always twice as large as this one. But what if I took the point not on this side of the circle, but on this side of the circle? Does this angle here look like gamma? Well, honestly, it doesn't, and it shouldn't be, because this angle points towards this arc, this huge arc here, while all these angles pointed towards this small arc here. And so for the case of this angle, we have that this one here, that corresponds to this whole arc, is twice as much as this one. And now because this is 360 minus 2 gamma, then this is half of that, which is 180 minus gamma. And this is similar to how before we had this picture here with this triangle, and this was the center, in which this angle was alpha, and we derived that this angle here is 2 times alpha. And it's similar to how here we have 180 minus gamma, and this angle here is twice as much, so 360 minus 2 times gamma. Here's the optional problem. We have a trapezoid in which this side is parallel to this side, and then we took 2 of the circumcircles in this trapezoid. The first circumcircle takes this point, and this point, so we draw the red circle. And the second circumcircle takes this point again, but this time it takes this point as the third one. And then we construct the blue circle like this. This red point is the center of the red circle, and this blue point is the center of the blue circle. It is given that the red point lies on this diagonal of the trapezoid. We have to prove that this blue point, the center of the blue circle, lies on the other diagonal. Here is the solution. First of all, I'm going to draw the blue point a little bit to the side so we don't confuse things. Now I'm going to take this angle here to be gamma. Then we've learned that because this triangle here has a circumcenter here, and one of its angles is gamma, then this angle here should be twice as much, so 2 times gamma. Furthermore, this radius equals this radius, and so this angle here is 90 degrees minus gamma because of the trapezoid and this line parallel to this line. And this angle here is 90 degrees minus gamma. It equals this angle. So in conclusion, we got that if this angle is gamma, then this angle is 90 degrees minus gamma. Now let's take a look at this triangle here. The blue circle is the circumcircle of this triangle, and one of its angles is 90 degrees minus gamma. And so if we take the center of the circumcircle, or the circumcenter, we have that this angle is twice as large, so it should be 180 minus 2 times gamma. Finally, this here is an isosceles triangle because this is a radius and this is a radius. And this angle is 180 minus 2 gamma. Therefore, that angle from the center to this point is gamma. So the picture looks like this. This angle given by the black line is gamma, and this angle given by the blue line is also gamma. And therefore, the blue line and the black line are the same line. And so the center lies on this diagonal of the trapezoid.